Hey everybody, and welcome to the second video for the cumulative review packet number 2. Let's start off here with number 14, which is asking us to take a binomial and cube it. And so in a similar way that we did number 11, that when we took a binomial squared, we wrote the parenthesis twice, when we take a binomial cubed, that really means you're multiplying 2x minus 3 times itself 3 times. So the annoyingness about this problem is that there's just a lot of multiplying that we have to do. And as a suggestion, let's multiply the second two so that we can have a binomial in front, and this will change to a trinomial. Kind of bear with me here. So let's ignore this first one, and let's just worry about these second two binomials. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2 is another negative 6x. And then negative 3 times negative 3 is a positive 9. So now, if I combine these like terms, these two binomials became this trinomial, 4x squared minus 12x plus 9. But that is still multiplied by the 2x minus 3 that we didn't touch yet. And so now I have a binomial times a trinomial. So if I first distribute the 2x to everything, 2x times 4x squared is 8x to the third. Multiply numbers, add exponents. 2x times negative 12 is negative 24x squared. 2x times 9 is a positive 18x. If I then distribute the negative 3, that would be negative 3 times positive 4x is negative 12x squared. Negative 3 times negative 12 is a positive 36x. Negative 3 times positive 9 is a negative 27. So my final answer in standard form would be 8x to the third. Combine these, minus 36x squareds, plus 54x, minus 27. Because there's no like terms, this would be my final answer in standard form. Next examples. Factor the following polynomials. Consider taking out a greatest common factor or by factoring by grouping. And this is the most recent lesson we have done here. So your goal of all of these questions is actually to do the inverse or the opposite of what we did here on numbers 7 and 8, that we multiplied the numbers and added the exponents when we're distributing in. So if we're factoring something out, we divide the numbers and subtract the exponents. So if I looked at number 15, if I looked at my 3 terms, we can't take something else out unless it's common to all 3 terms. So if I look at 18, 12, and 6, the largest number that divides into 18, 12, and 6 is actually 6 itself. So I would take out a 6. Then I look at x to the 5th, x to the 3rd, and just x to the 1st. Because all 3 terms have an x, I'm allowed to take an x out. And I'm only allowed to take x to the 1st out because that's the lowest exponent that I see. I can't take 5 x's out because I don't have 5 x's here to take out or here. If I look at the y's, I have y to the 7th, y to the 3rd, and y squared. I want to take out the smallest exponent of y squared, then put in the parentheses what's left over. So if I take a 6 out of 18 and divide, I'm left with 3. X out of x to the 5th, subtract the exponents, x to the 4th. Take 2 y's out of 7, you're left with y to the 5th, plus. If I take 6 out of 12, I'm left with 2. X out of x cubed, I'm left with 2 x's. Y squared out of y cubed, so 3 minus 2 would leave me with y to the 1st, or just y. Last term, if I take 6 out of a negative 6, I'm left with negative 1 technically. X out of x is gone. Y squared out of y squared is also gone. So this would be my final answer. This is my greatest common factor in red, and what's in here is the remaining pieces of my terms. Number 16, if I look, and I'll bring my work down a little bit here, if I look at 8, 24, and 4, the smallest number I can take out of all of these is 4. So I'm going to take a 4 out. If I look at A, I notice that there's no A's in all 3 terms, so I can't take out any A's. I also can't take out any B's or C's. They don't repeat in all 3. But I do notice I have x squared, x to the 5th, and x to the 7th. So I can take x squared out, and if I do so, I'm left with, let's see, 8 divided by 4 gives me 2, and I'm left with a, but if I take x squared out of x squared, that's gone. So my first term is now just 2a, minus, take 4 out of 24, and negative 24, that is a negative 6, b, take 2 x's out of 5, I'm left with 3 of them, and then if I take 4 out of 4, I'm left with 1, because 4 divided by 4 is 1, c, if I take 2 x's out of 7, I'm left with 5. So this would be my final answer here, this being the greatest common factor, and these are the terms that remain. So notice that 15 and 16 both had 3 terms, so I couldn't use factoring by grouping. However, as soon as I do have 4 terms, like number 17, that are all not like terms, I'm going to try this method of factoring by grouping. And what I want to do is look at the greatest common factor of this pair and the greatest common factor of this pair. So let's try that out. What's common between these 2 terms? Well, just an x is. And if I take the x out, I'm left with y minus 2z. If I look at the second 2 terms, I can take just a 5 out, and I'm going to carry down that plus sign. So plus 5 parentheses. We take 5 out of 5y, I'm left with y. We take 5 out of negative 10z, I'm left with negative 2z. The good news here is that my parentheses match. In order for factoring by grouping to work, they need to match. So what I'm going to do is think about removing these 2 parentheses, like if you could pick them up and toss them aside for a little bit. This represents another greatest common factor. So y minus 2z would be one of my final parentheses, and then what's left over would be my other parenthesis. So this factored to be y minus 2z times x plus 5. And if you wanted to check your work, you could go back and distribute everything, and you should get back to the original problem. Number 18, I notice there's 1, 2, 3, 4 terms again, none of which are like, so I'm going to try factoring by grouping. If I look at these first 2 terms, I can take out a 2, an x, and a y. And if I do so, I'm left with 3x only, because the y's cancel out. If I take 2 out of 2xy squared, I'm left with 1. The x's disappear, but I'm left with y. If I look at the second 2 terms, I'm going to carry down that minus sign there. The biggest number I can take out of 27 and 9 is 9. And then if I do so, I would be left with, let's see, if I take a negative 9 out of negative 27, that's a positive 3x. Negative 9 out of negative 9y, that's a positive 1y. That's left over. Just like the last example, I know I did this right because my parentheses match. So one parenthesis would be what I took out, 3x plus 1y, and the other parenthesis would be what's left over, 2xy minus 9. And again, if you're unsure about your answer, feel free to distribute and see if it works out. Factor and solve the following equations. The key to these is still the greatest common factor. So if I looked at number 19, I notice that it's equal to 0, which is what we need in order to factor and solve. I look at these 2 terms, and I notice that I could take out a greatest common factor of 4x. And if I do so, if I take 4 out of 4, I'm left with 1, or it's gone. If I take x out of x squared, I'm left with just x. 4 out of 16 is 4. X out of x is gone. So now, because of the zero product property, as we talked about in class, I can set 4x equal to 0, and I can set x plus 4 equal to 0 and get my 2 answers. The first one would just be x equals 0, and the second one would be x equals negative 4. So that means that either one of these answered, if plugged back into the original equation, would be true. Number 20 looks different than 19, but I want to tell you that it's really not. In order to factor, we again need everything equal to 0. So to do that, what I'm going to do first is subtract the 15y over, and if I do that, I'd get 6y squared minus 15y equals 0. And remember, these are not like terms, so I can't add them. But what I can do is think about the GCF again. If I look at 6 and 15, the biggest number I can take out is 3. If If I look at y squared and y, I can take a y out. And if I do that, 3 out of 6 would be 2y. 3 out of 15 is minus 5. Y out of y is gone. So then that still equals 0. If I use the zero product property again and say that 3y equals 0 and 2y minus 5 equals 0, then I can get two possible answers for y. Again, I would get an answer of 0. But for this one, if I added the 5, I would get 2y equals 5. So y would be an answer of 5/2 or 2.5. So again, if you could plug these back in, they should both work. All right, some review of exponent rules. You're going to keep seeing these on your cumulative review packets. You want to rewrite everything with positive exponents, no negatives please, and no decimals. If you have a numerical base, you want to simplify completely. So if I look at 21, I notice that I have like bases, and when I have like bases that are being divided, I really subtract the exponents. However, the 3 and the 18 are not like bases, and so I want to leave all my answers as fractions if possible. And so what I want to do with the 3 and 18 is divide, or in a better case, I want to reduce. 3/18, if I divide both by 3, is really 1/6. Now, I have the like bases of x, and I subtract the exponents. So it would be x to the 7 minus 3 power, and y to the 3 minus negative 5 power, which really ends up being a plus. Now remember, when you do the subtraction rule, everything ends up in the numerator again. So right now you have 1/6, x to the 4th power, y to the 8th power. I do not see any negative exponents, so we're going to leave everything where it is, and I'm going to write my answer a little bit more simply, is x to the 4th, y to the 8th, all over 6. And yes, the 1 is still technically in front, but we don't need it anymore. Number 22. I always want to simplify the parentheses first if possible. So I'm going to raise both of these to the 2nd power. So I'm raising this monomial to the 2nd, so negative 2 squared, x squared. I'm going to copy everything else as I see it. I also am going to simplify. I know that this is really, negative 2 squared is really 4. And so if I look at the problem, what I have next, I want to multiply the numbers and add the exponents. So 4 times 8 would get me 32. X squared times x to the 5th is x to the 7th. And then y to the 5th times y to the negative 2nd, if I add the exponents, would be y to the 3rd power. So my final answer is 32, x to the 7th, y to the 3rd. Number 23, let's raise everything in there to the 3rd power. And I have 1, 2, 3, 4, 5, 6 bases. So I'd have 3 to the 3rd, x to the negative 12th, y to the 15th, because it's a power to a power, you multiply the exponents. 2 to the 3rd in the denominator, x to the 18th, y to the 3rd, because this is really y to the 1st. If I simplify a little bit, 3 to the 3rd is 27, x to the negative 12th, y to the 15th, over 2 to the 3rd, which is 8, x to the 18th, y to the 3rd. Just like the previous example, when we have like bases and we are dividing, we subtract the exponents. So 27/8 cannot be reduced, and I'm not subtracting these because these are not like bases, so I just need to divide them or reduce them. But I can subtract these exponents, x to the negative 12 minus 18th power, and y to the 15 minus 3 power. So I'd have 27/8, x to the negative 30th, y to the 12th. Because this is negative, it has to flip down in order to be correct. So my answer would be 27 y to the 12th over 8 x to the 30th. Final answer. Because I cannot take anything out, 27 and 8. Last example here, I'm going to raise everything in here to the negative 3rd. So that would be 2 to the negative 3rd, x to the negative 9th, over 3 to the negative 3rd, y to the negative 12th. And because everything is negative, we're going to have to flip everything. Now, because I'm running out of time on this video, I will finish this problem in the next video. Thanks, everyone.